G'day Year 10s, welcome back. So today we are looking at how to use technology to compare simple and compound interest. The actual information you need is the same as what you already have. Simple interest, the interest equals the principal times the interest rate times the number of years. It's only ever paid on the original amount, the principal. To get the total amount, we do principal plus interest. You may not have seen it written like this, where we replace that interest. We know that the interest is PIN, so I could say that the total amount is the principal plus PIN, principal times interest times number of years. We're going to use that formula here, and we're going to use this other formula here, compound interest, which we know. I'm using the extended formula, the one where we've got the number of rests, so we can change how often it compounds. So the total amount we end up with is the principal bracket 1 plus the interest rate as a decimal divided by the number of rests, how often it compounds per year, all to the power of the total number of compounding periods, so the number of years times the number of rests. And we're going to look at this example here. We're going to compare 5,000 compounding at 5% interest and 5,000 at simple interest over a number of years. Now it says for 3 years, but we'll actually do it for a period of years. And let's go and use Desmos to help us do that. So you can see here in Desmos, alright, so over here in Desmos, you see I've got my two equations here. The compound interest one up the top, principal 1 plus the interest rate divided by the number of rests to the power of the number of years times the number of rests, total number of compounding periods, and down the bottom, that special version of the total amount being the principal plus the interest, and of course the interest when we're talking simple interest is PIN. So what values did I need to put in? We had a principal of $5,000. So let's change that P value to be 5,000. The interest rate was 5%. Now, because I'm substituting it in here, remember 5%, I'm going to make 0.05. That's how we write 5% as a number. And how many times was it compounding per year? It was compounding, I think, annually in this first one. We better go back and check. Compounding annually. So that's easy enough to do. We can keep the number of rests as 1 at the minute. So, if we look at our simple interest formula first of all, you can see we start off at $5,000. Yeah, that's how much I put in at time 0. As we go ahead, they wanted us to find the value after 3 years, so we go 1 year, 2 years, 3 years. The value is going to be $5,750 after the 3 years. Compound interest, what's going to happen is, so that's gone up by the same amount each time. Sorry, I should have mentioned that as well. If I get that on one, you can see it's going up by $250. Another $250 when I get it to the right point. And then one more 250 gets me to the 5,750. And that happens because simple interest is only ever worked out on the original amount. That 5% is going to be 250 every year. It's going to increase by 250 each year all the way along, going up at a constant rate, straight line graph. Compound interest looks a little bit different. Now it doesn't look too different initially. You can see there, compounding annually after 1 year, it's going to be the same. After 2 years, the first one was at 5,500. This one at exactly 2 years, if I can coordinate my mouse. Which I had it. You could see there, it was just a little bit more than 2,500. In fact, well, you can see there we go, 2,512.5. So it's increasing. What happens over time is because that interest is compounding, it grows and grows. And you can see there, by the time we get to 10 years, there's quite a significant difference between 7,500 and 8,140-ish, 50-ish. And the further you go into the future, the more that compound interest really starts to take effect. And you can see, if you kept money, if you started putting money away now for your retirement, by the time you're looking at 50, if you were putting it simple interest, 50 years ahead, so maybe 65, that's about when you're going to be retiring. You could have 17,500, or you could have 57,500 nearly. So compound interest growing over time. This is useful for you to be able to do. You can also do this on your graphics calculator. If you have a graphics calculator, we might show you how to do that in class. But really all this exercise wanted you to do was to get an appreciation for the rate of increase of compound interest versus simple interest. And you can see here how significant it is. Nothing new in terms of doing your work. You can copy those formulae and have a play around in Desmos if you want, but otherwise just tick off a few of the questions. You don't need to do too much in this one because it's the sort of thing that you're not going to be asked in an exam, but it's just good to get an appreciation of. I could ask you to figure out algebraically when they're going to intersect or something, but you wouldn't be using your calculators for that. All right. Thanks for sticking around. Good luck with that, and we'll see you in the next video. Bye for now.